What was Palantir Gotham? What were you working on? Why was it hard?
Well, I think the really funny thing about Gotham was the hardest part was we had no idea what it was supposed to be at the beginning. So the goal was to build this platform for the intelligence community. So basically software for spies. But as you remember, the first hard problem about a spy is actually finding one, right? And then once you find one, they don't actually want to tell you what they're doing.
They want to tell you cool stories about using guns and like little devices and stuff, but yeah, not really about the information architecture.
Or you try to ask them what they're doing, and they're like, oh, that's classified, and they give you some sort of tortured baseball analogy. And so instead of all the UX books that you interview your customers, you try to find out what their problems are, and you build something to solve their problems, and we couldn't do that. And so basically what we had to do was we had to build the product we thought they needed, which was wrong, and show it to them, and they would tell us we were wrong. They'd be like, oh, this is crap. Why don't you build this other thing instead? And we would do that, and you and Stefan would go into DC and show this to them and bring back that feedback.
It was a combination, because I do think there were certain first principles, but we all kind of could figure out they would definitely need. And then there was the iteration of what they actually needed. And so we had to have like a lot of both sides, right?
We knew it was something about data, that somehow we had to get their data in, and that we would let them ask questions about their data. But we were totally wrong at the beginning about what kind of data they had.
They had a lot less structured data than we assumed.
Exactly. Yeah. It turns out intelligence community, it's all about reading documents and trying to understand and parse documents and figure out who the people are in the documents. And if the person in this document is the same as that description they have in the other document.
They had spent over $30 billion on databases and gathering data, so I assumed that they had more structured data. So that was pretty complicated.
Yeah, and that was mostly wrong. I think they had it and they didn't know what to do with it.
Do you remember any of the characters? One of my favorites was Sir Mark. Do you remember him?
I do. Yeah.
I think he was the one who said that if you don't get your gun unless you're going to use it, and if you're going to use it, pull the trigger twice. He's the MI6 guy. Do you have any other favorites?
I remember. I think I have to stick to first names here, but I remember our first customer at the agency. Her name was Sarah, and she was the only person that believed in us. I think the really crazy thing about Palantir was how long it took to get a product that actually worked. I think it took 3 years before we had anyone using it to solve.
I remember a few
problems.
people almost quit right around year 3, right before that happened, and it was like this thing where like people were so exhausted, like this is just crazy and it's not going to work, and then we got them to stay on. And then we kind of got over the hump and people started using it.
I remember that. I remember, and this is one of those things about the really great engineers is that a really great engineer wants certainty, right? They don't want to, they've been doing something for 3 years. All they can see are all the problems that are in it. Yeah. And, I remember sitting down and having a conversation with our best engineer and just sort of convincing him to stick it out for 9 more months. And he built the security system that we ended up working with. It was a critical piece to allowing us to actually deploy. And then he quit.
Yeah.
But if he had...
Well, thank you for holding the team together. We were both fighting hard to hold it together because it was kind of like, what are these kids doing at that point? I don't know if you joining was really, really critical to Peter giving us like our money for the second time because he was like, you guys got Bob to join? How'd you do that? So
I did not know that.
That was actually, yeah. So thank you. You're a good indicator for Peter Thiel.
You've kept that a secret from me for all these years.
Well, just forgot to tell you early on. Well, we all did very well from that. But you may even be doing even better financially from OpenAI. Not that we're talking about finances, but this is amazing. You guys have just crushed it in terms of changing the world the last 6-7 years. How'd you find OpenAI? What's the story there?
Well, when I left Palantir, I could see, so my PhD before I started Palantir was in AI. And I left because I felt AI wasn't happening. And this was 2005. And in fact, AI was not happening in 2005.
Yes, it would have been very hard to work on AI 20 years ago.
The key thing about AI was actually just big data. And you didn't need AI to unlock it.
The lesson was that everyone who went to work on this it was just like a bad choice forever. It was exciting, but then it was never the right choice.
Yeah, until it was.
So how'd you know that it was? Like, how'd you have the intuition that it might be?
Well, so what happened is in, I think, 2011, there was a paper that was published by Eliot and some other people Eliot's our chief scientist at OpenAI, where they basically reinvented neural networks. And they showed that if you ran them on GPUs, you could plug in huge amounts, much bigger amounts of compute and much bigger amounts of data. And neural networks went from being, that one thing that you can kind of use for handwriting to something that was actually the best way to identify images.
And for some of our listeners who aren't as technical, we're talking about a neural network. That's something that gives iterative feedback on things. Explain how would you explain neural network?
So neural network, the analogy that most people use is that it's like the brain, and it is, but at a very, very high level. So a neuron is basically, you can think of it as having connections to other neurons. And the strength of those connections determines when, the first neuron, the lower level neuron fires, then that makes the higher level neuron fire. And if you train these, you do it by showing them the right answer and then basically doing what's called back propagating the error, from sort of the top of the network where the answer is all the way back down through the whole network.
So these things are learning patterns, and is it a pattern detection type of situation then, or what is it with the flashing, what they're detecting?
Yeah, you're building hierarchical representation. So at the very bottom, think about a vision network because it's easy to visualize. So at the very bottom, the neurons are detecting edges, and then they go up a little bit higher and they're detecting corners. And if you go high enough, they're detecting wheels, and then above that, they're detecting cars.
If quarters in this way, then it's a square. If this could be a wheel, and then it could be a car. Got it.
Yeah, and at some point, there's a Joe Lonsdale neuron that is out there. And individual people, you can actually find these neurons in the networks.
I remember reading On Intelligence by Hawkins, who didn't actually end up solving all these problems, but he said there's like 6 layers of the neocortex that is part of the vision system. Is that right, or is there actually a lot more than that?
I'm not a cognitive scientist. So the other thing is, I think the analogy between the brain and the neural networks, it's very inspirational, but you can take it too far.
It's very imprecise. What OpenAI did is you basically didn't base it on the brain. You based it on like building it up from scratch, from just first principles.
So I think that the thesis behind OpenAI, when I joined in 2017, was that neural networks were the final architecture that could take AI all the way to human level intelligence, or AGI.
But wasn't there a transformer breakthrough that was really important though, right around 2017?
Yeah, that's right. So the first couple of years of OpenAI, we were using sort of standard neural networks, and then there was a paper at Google. Some people came up with an idea called transformers that allow you to take better understanding of the context. So, for example, you could look at documents, and now you could really understand the preceding 3 or 4 pages, when the prior architectures had struggled just to understand like the previous 10 words.
What's the intuition for why transformers worked better? Like, what's going on there?
It's basically because they have a notion of attention. So you can pay attention to particular words in a document versus the previous architecture had a notion of memory. So you could sort of remember the words that you had seen, but it's much easier to be able to look at a sheet of paper and sort of see the different words and think about, reading those words.
Pay attention to what matters.
Pay attention to what matters.
Which is kind of how the brain works. Things jump out at us, obviously, when we look at things.
Yeah, it's very intuitive.
The intuition, I know this is not based, you're not a cognitive scientist, but I want to try to build intuition here for people. Yeah. My understanding, the big breakthrough we had for how the brain works is you're constantly predicting what you're going to see next. Like, this may be why we see ghosts, but either way, your brain's constantly looking at what it thinks it expects to see, and then if something is not unexpected, it kind of jumps out at you. Is there anything like that with transformers, or there's nothing like that where it's trying to predict things?
Well, that's exactly how you train a model like GPT-4. So, if you take it to train a model like GPT-4, basically we take all of the text, everything we can scrape off the internet. And what the model is trying to do is it goes character by character, and it's trying to predict the next character. So, if it sees, the rain in Spain falls mainly on it's going to guess, oh, that's a P, and it's going to be plain. And it does this over and over again for huge amounts of documents, like trillions of characters. And over time, it seems as though that yields something that looks like intelligence.
The prediction seems very, very similar to intelligence, which may be what we're doing too.
Yeah, I at this point, I think we understand neural networks a lot better than we understand the brain. So whenever someone talks to me about the brain, I always think, well, what does a neural network do? And then probably actually the brain does that.
Do you think of yourself as a neural network now?
I do, actually. I actually think of my kids as neural networks.
How has that changed your interactions with them?
As I was starting at OpenAI, first I worked on robotics, and then we did some problems with math and then programming. Yeah. And early on, the kids would always get the problems before the robots were. And now it's the other way around. Now the neural networks are better at solving problems than the kids.
Has it given you any intuition on how to train young minds?
Yeah, you just show them lots and lots of things, and you just have them read.
Just show them 3 trillion things.
I mean, that's probably how you and I learned, right? Just read a lot of books when we were kids.
I guess there's a thing about attention too. I've always found that kids do better when they're confident. I don't know if the computers need to be given confidence, although maybe that's a signal for something else like attention.
Well, that's actually one of the cool things that we've discovered with GPT-3 and GPT-4 is that the models are trained on the internet, and they're reading everything, right? Then they try to act like what they've seen, right? They're predicting. And so they don't know whether to predict being someone who's dumb or someone who's really smart.
That's why you have to tell them they're really smart when you're talking to them. It's so funny.
Exactly. Like you're a confident, powerful physicist who knows everything, the best physicist in the world. Now answer my question.
And you sound like Shakespeare because it's fun if you make them sound cool.
That's right. Or you have to do everything in a limerick.
That's pretty good. So let's back up a little bit. So you joined OpenAI in 2017. What's your role in OpenAI?
So I'm the VP of research.
What does that mean?
So so if you're the VP of engineering at a company, so Palantir, what I spent all my time doing was basically, fundamentally you're trying to figure out, are the right people working on the right problems, and figuring out what's most important and finding people to work on that.
You would get in the problems yourself too, but then you're more focused on the people than the.
Yeah, I mean, especially early on, I read every commit, and I wrote a lot of the back end for Palantir. But as the company scales, you as a leader end up focusing more and more on the people problems, and in a normal company, you're often trying to figure out what the people should be working on, and at a research company, it actually doesn't work very well that way. So. There's this researcher, Aditya Ramesh. He built a model called DALL-E, which allowed you to take a description and build an image out of it.
It's very fun.
He spent 2 years working on that.
Wow.
For most of those 2 years, no one other than him believed it would work. I mean, I sort of believed it would work. I really hoped it would work. I made sure he had the GPUs he needed.
Yeah.
But, if in order to have that kind of drive, to really push it through for 2 years, this is your dream.
Yeah, you have to be obsessed with it, basically.
Yeah. And I remember, Karp always used to talk about this, that the best engineers were artists, right? And if you want to keep an engineer happy, what you actually have to do is just let him do his art. Just get out of his way, let him do his thing. And your job as when you're building a company is to have all these brilliant people doing their art, and somehow magically it turns into a product that solves a real problem.
What are some of the most important lessons you guys learned from Palantir?
Yeah, so I think the three things that really kind of resonate and continue to resonate, one is, I guess I should just caveat to start, unbelievably grateful for the opportunity and experience to work at Palantir. I think it's an incredibly formative experience for me in my life. I think a couple of the lasting impressions. One is take on hard problems, just seeing firsthand how we can actually have a huge dent in really big, ambitious problems that are, I think for a lot of people's imaginations, just kind of unsolvable. I think giving us that sort of space to work on those things was one big one. I think another big one was just really heavy focus on the quality of the people. Just seeing firsthand the amount of energy, tradecraft, care that goes into the hiring decisions that were made at Palantir, and then the quality of the people that they were able to bring in, and then how to deploy those people against the problems. I think that was number two. And then I think three was really just really heavy focus on going to first principles, thinking about what is the actual problem we're trying to solve, and then getting really tactical.
Awesome. You said some good things about Palantir. What are things you'd want to change and do differently?
Yeah, I mean, I think the big thing that I reflect on having now left Palantir is obviously there's a lot of stuff we wanted to kind of bring from the Palantir experience to what we're doing at Candid. I think if there were one thing that we're probably doing somewhat differently, it's a much narrower and tighter focus. I think Palantir was often kind of solving a wide range of problems across most industry sectors.
Try to build something that could go everywhere at once.
Everything for everyone, always.
Very much my personality as a 21-year-old.
Yeah. And at Candid, it's quite the opposite. At Candid, we're solving making medical insurance billing better for healthcare providers in the U.S. And that's a pretty tight focus relative to, everything for everyone everywhere.
And it sounds like medical insurance billing is a pretty small problem, but I guess it's about $280 billion a year spent on this.
It's a massive industry.
It's a huge industry. So one of the reasons I wanted to talk to you guys and show people what you're doing, aside from the fact that you're top talent from Palantir and I'm excited about your company, is there's this theme in the economy right now, which is that there's all these areas we spend tons of money on, and it looks like the new advances in AI, it looks like really top tech cultures combined with AI can make these areas more efficient, could actually meaningfully impact the productivity of the economy. I mean, $280 billion spent a year, that is a meaningful part of our GDP, right? It's that's a big amount, and it looks like you guys are gonna be able to make it more efficient. So first of all, before we go into this, what is medical billing? Why is this costing $280 billion a year?
It is, medical billing at the highest level is the process of that a healthcare provider goes through to get paid by a health insurance company or by patients and sometimes employers in the US. And so there's a bunch of steps in that process, starting from going in network with insurance to ultimately submitting claims and to the insurance company and then getting those claims adjudicated. In that process in particular, which is where we focus, submitting claims, submitting the correct claim to the correct payer is extraordinarily difficult.
How many payers are there?
Over 1,000. And
then how many types of claims are there?
There are many types of claims. I think probably thousands of different procedures or codes that you can actually submit to insurance. And all those over 1,000 insurance companies literally have different rules for how to submit the claim.
Why did they normalize?
That is a great question. They didn't. They standardized the form, but they did not standardize the field, what you put in each field in the form. And so they might be like, one pair might be in this box, I want a taxonomy code. And if you do not put the taxonomy code, I will deny your claim. And another pair will actually they don't care about a taxonomy code. So you need to know all that stuff. And the process, what we're focusing on is how do you, why this is so expensive and so manual is because there's no good software today. People have to do this by memory, or they're like creating their own rules, or they're like doing things, they're hand jamming. There's a lot of manual work to actually try to do all of these things correctly the first time. And there just hasn't been any good software built to do this stuff for them.
Well, it just seems like an infinitely complicated problem for software. You have to have people who become experts on this. I mean, are these people paid a lot of money because there's like, or do they have just like a large book that they're reading to do it? Like, how do you figure this out when like, how do you know what to put where?
There some pairs, it's a mix. Some pairs will publish stuff. So there might be some PDFs. Sometimes pairs won't tell you and they haven't published anything, and you need to submit a claim, and then they do something, and you literally will call the pair and they'll tell you why they adjudicated and what they want you to do.
Do you have something that helps people call them and take notes then? Because sometimes you have to call even if you're perfect.
We're focused on, we will call if we have to learn these rules, but what we're focused on is we want to take that feedback loop of we want to submit as many claims correctly the first time. And so we're trying to emphasize call fewer times. Cluster your claims, find which ones were denied for the same reason, make one call. Don't call for all 1,000 of the ones were denied.
That's smart.
Take that rule, put it in the rules engine, and don't make that mistake anymore. Just move on to the next thing.
Another way to think about the like dimensions of the problem is think of like 10 or 15 different disparate data sets that don't really have purpose-built systems. And the task of medical insurance billing is like perfectly aligning to the center of those overlapping Venn diagrams every time you submit a claim. The challenge is that there are like many, many, many different specifications of the rules that need to be followed to submit a claim properly. Moreover, the payers are also at the mercy of their legacy system. So as much as a payer might codify a policy in a PDF that they release quarterly, they have a 30-year-old system that they're instrumenting to adjudicate these claims. So it's buggy, as you can imagine.
So sometimes they might accidentally reject something and you have to tell them that they messed up.
In fact, there's a great story of times when...
Yeah, actually, I know there's a large payer that I know manually processes 1 in 8 claims because their adjudication system doesn't do it. Wow. It's a large payer. We'd all know the name of it.
Do you think eventually you could help them too with what you've built?
I 100% think we could, because if you think about what we're doing, we're pre-adjudicating the claim. We know how the payers, we know what the payer wants on their claims. We know like what their rules are for how to submit a claim. And there's a bunch of noise of it. Every time they deny these claims that were could have been avoided, the provider's going to have to call the payer, and now the payer needs to pay for support people to answer those questions. They don't want to pay for that, I don't think. And so there's very much a role where I think we could just sell what we're doing, our rules engine, back to the payers and be like, look, we're pre-adjudicating these things. You would have adjudicated it anyway, and I can save you the support staff money.
So Nick, you're the co-founder and CEO, and Doug, you were looking at a bunch of options and you ended up joining here early. Like, what made you guys passionate to do this? Why is this the thing you want to spend your lives on? You're extraordinarily talented guys. Like, what about this is interesting to you?
A couple of things. One, I was looking for a good business, and I think I subscribed to the Polygram. I think it was Polygram, saying like unsexy businesses are the ones that can scale really big. And I, for better or worse, get excited about unsexy businesses. I think like Stripe at one point was an unsexy business, like payments, and they made it cool. I also think it is a very worthy problem. At the end of the day, most of the time, I'm sure we've all heard about patients who have these crazy bills by insurance and they get owed this thing. And we end up saying like, oh, insurance are jerks for not wanting to cover that. And in some cases that is true. In most of those cases, the provider submitted the claim wrong. And so like at the end of the day, what we could be doing if we help all of our providers do this right is we're dramatically improving patient experience, which I think is a very important problem.
It's a good mission. I mean, do you actually think about like if right now it costs $280 billion a year, should it cost half that much or something if someone's doing this better?
Easily. At the end of the day, there's no software. They're throwing bodies at the problem. The last innovative thing we did in this industry was offshore it.
I guess you want to make it cost like a much, much smaller fraction of that, but then capture most of that yourself.
Exactly. That's right.
What are some of the lessons you brought with you from Palantir to Saltbox?
It's probably the case that my colleagues at Saltbox get annoyed with how often I mention Palantir. But I don't care. It's worth it. Look, why don't we? I think let's talk about some of those lessons, and then and then we can kind of
Sure.
maybe pull them forward. Is that
Sure.
okay?
Let me know. What are some of the big lessons for you?
I would say that first, there's this tremendous lesson in the value of building a truly mission-oriented company. Of course, every company has a mission, but the reality is they typically are, BS, or something on that spectrum. And Palantir is I can't imagine a company with a more visceral and real life mission. You and I both have friends who, were in Afghanistan and Iraq, and and difficult parts of difficult cities all over the country, and doing all sorts of things, living out that mission. And the benefit of it, I believe, is that building a radically ambitious company like a Palantir, it obviously calls upon the very, very, very best that the very best people have to offer. And in order to get the very best, you have to have mechanisms of incentive that go beyond compensation. It's just not sufficient. And the greatest mechanism of incentive is to give one the opportunity to actually make a difference in the world, I think. Yeah. And so many people in so many different ways discovered that potential at Palantir. And as a result, gave literally their all, literally. And you get what you get out of that, right? You get a company like that. And so, I think that for me, is probably the most quintessential lesson, that if you have the privilege of building a radically ambitious company that is also truly and materially mission-oriented, then that is a rare opportunity. And it's just like tremendous fun.
I love it. No, I totally agree. This is what it really comes down to is like the beyond any amount of money anyone's going to make, like people really care about making a difference in the world and being part of a great team they're making that with, right? It's having people around you who are similarly motivated. Mission-driven cultures are so hard to create, but I agree. There's something magical.
You can't really create. I would argue that you don't really. I mean, certainly there you cultivate them.
You cultivate
but
them.
The mission, the creation of a mission-driven culture is a company that's building a product that has an actual mission, and where that mission, makes a difference in the world. Period. Yeah. You can't make it up.
The brand kind of ends up, and the culture kind of comes from the stuff that's real. You can't just make it up.
That's right. I mean, I remember, and you surely were part of some of these, but it was almost we almost had a script for it. The 3-star general would come in, pre Palantir, or we'd go visit them, of course, and they'd be like, go put on some clothes. Like, what do you got? We're not working with you guys, and but then inevitably
it goes back to you're not wearing shoes, huh? You're still scarred by that.
Yeah, inevitably there would come this moment. We've seen this many times where that general would come to Palantir for the day, and they come in a little skeptical in the beginning, like, what the hell is this? But by the end of the day, they love us, and many times I observe where they would say, go bring those guys into the cafeteria, and I want to give them a speech. Generals love giving speeches, I guess. Yeah. And they would give these speeches, and they would basically say, I was a little skeptical of you guys, but
we were a little bit weird compared to what they're used to.
We were very weird, very weird. Yeah. But but here's the thing, I've seen the impact of this technology firsthand. I've seen the way that it's making our soldiers' lives better, saving their lives, etc. And I just want you guys to know how important the work you're doing is, and how much we appreciate you, and all these things. And people, there'd be tears. There'd be tears, and for good reason.
Yeah,
it's like, yeah, you did something important here. And so again, you can't make that up. Yeah. And when you have a company that has that sort of impact in the world, people will give the very best.
They will. And it was a key early on in the company bringing those people in once we really started to have the impact, because people even internally, Tyler, as you probably know, like the first year 4, year 5, it's tough getting to the point where we were making this work. So we got to keep convincing them. And it is key when you see the impact directly from the people out in the field and coming in. That's critical for it. I want to tie these to the current things you're doing a little bit. I'm curious. Tell us about Saltbox. It's an amazing company. I'm very bullish on everything I've heard. So how did you get going on Saltbox and what are you doing?
Yeah. I started Saltbox in 2019. It was inspired by my experience in having bought having bought True Glory, and I always thought, Joe, that in some ways, I feel fortunate to have had this kind of master plan, which has actually worked pretty well. The plan was, leave the Valley and take that knowledge and connectivity and culture and technology and go and embed myself in the real world and discover some interesting problems and built a little business in the course of that. But the problem I discovered was, quite interesting. What I realized in essence was that as a small business, which of course is is a hugely critical part of our economy, they have incredible digitally enabling tools to help power e-commerce. And those tools work very well. You think of the Stripes and Shopify's and MailChimps of the world. The digital aspect of their world is beautifully organized, but there's this entire other aspect, which is a physical aspect of the world of an SMB commerce entrepreneur, and it is just a disaster. We're talking about interactions with suppliers and receiving pallets and fulfillment and access to carriers, so on and so forth.
Yeah.
And I saw that discrepancy and thought that it was a serious challenge, a serious threat to the long-term viability of the SMB. And the logic there is very simple. The logic is clearly no one believes that digital commerce will not continue to dominate commerce growth in the U.S. That's clear. Digital commerce requires logistical excellence. These two things go hand in hand. They cannot be separated. And logistics is inherently complex, and it's inherently capital intensive. And these are two things that are like kryptonite to a small business. You want to kill a small business, you just pour a little complexity and capital intensity, and they will die. So we want them to survive and thrive. And so what that tells us then, and what that told me, back in 2019, was that, in order to solve that problem, we've got to find ways to do two essential things. The first is we've got to, find ways to aggregate the demand of the SMB, because they do not have the wherewithal to solve for that capital intensity on their own. And that concept plays out in many parts of our business, which I can describe, both with respect to physical world, but also digital software that we're now building. The other thing we have to solve for is the complexity. And that requires that we think about the entire logistics stack, from the physical infrastructure and the aspects of that which the SMB needs access to the very top of that stack and digital tools and such.
But what years were you at Palantir?
I was at Palantir. So I came out to the Valley. I was one of those people who had the misfortune of graduating into the 2002 recession from undergrad, and then in the 2009 recession from business school from Kellogg. So moved out to the Valley, as you know, it was like a much quieter place back in 2009. And I remember having a conversation with someone, just asking somebody, like, what are the most exciting companies out here? And somebody said, well, there's this company called Facebook, which we all knew, right, which at the time had 100 million users. It sounded fantastically large. But the cat was out of the bag on that one. And then they'd mentioned this cool company that 50 people at the time called Palantir. And what resonated with me then was just that it sort of married the two worlds, the one world that I knew pretty well, which was Washington, D.C., having grown up there, but it also married this world that I so much wanted to be a part of, which was this sort of world of technology. So I knocked on Palantir's door several times before they actually let me in. There's a strong anti-MBA bias at that company, so
there's only rare exceptions allowed. That's
only
true.
Rare exceptions. So I think I got in on my second or third try, and I kind of But it was a fantastic ride. And, where I focused my efforts on was sort of early business development into some federal agencies, non-security related, but then also trying to get these big data companies, the LexisNexuses of the world, to play nice, I think, with the Palantir ecosystem in order to sort of enrich a lot of these investigatory and sort of data outcomes that Palantir was driving towards. So.
And then you were at Blend for a little bit as well.
And then I was at Blend. I joined a group of extremely talented sort of early Palantir employees at this other company called Blend, and got to be part of that sort of, as like first 20 who were looking to bring mortgages to the mortgage applications to the phone. And at the time, it was kind of considered outrageous. We had to convince people that, hey, people don't want to walk into a retail branch and fill out a 5-page mortgage application form. And that's kind of when I joined.
Very, very backwards industry you guys brought to the cloud. You have, I think there's over $200 million of revenue in banks now, so that it worked. Although the NEMA has to kind of pull out of the current market situation, but I'm still bullish on it.
Yeah, absolutely. I think it's super exciting. It's really impressive what they've done there, and again, a lot more innovation. I think that the credit unions and banks can take here.
And you've played fintech, crypto type stuff, and then what brought you to Anduin? What is Anduin?
Well, Anduin is and by the way, the name Anduin comes. I have a weakness for companies named after the Lord of the Rings. So Anduin is the land of the rivers from the Lord of the Rings, and it is a startup that was really rooted in a lot of the pain that people feel when transacting in the private markets, aka any company that isn't public. And if you're an individual investor, it is extremely painful. It's a very exciting world because you're accessing the returns and the diversification that these hedge funds and private equity shops provide, and that's very exciting, but it's a highly analog process, and there's a lot of pain involved at every single point in the process.
It sounds a little bit like Blend, with you filling out 5 pages for a mortgage.
My entire career has been about this sort of tech arbitrage into these sort of highly analog spaces.
So if someone wants to buy a stock, they go on their Schwab or their Robinhood app, and you click a button and you're done. Or in my case, I call my family office because I'm too lazy to use the thing myself. But for normal people, now it's a click. But if you want to actually buy into a fund, or you want to buy a private stock, there's a lot more complicated process.
You have to fill out, oftentimes it's called an LPA. It is a 50 to 100 page static form that is very dense and is filled out incorrectly 90% of the time. So the industry has a term called NIGO or NIGO, which means not in good order, which means any one of these documents have one or more errors, and it leads to horrible investor experiences. It leads to costly delays. And I can't tell you how many emails I get from friends. They send me emails with subject headers, FML, and it's sort of a 20-threaded email that they have. They want to make an investment. They're talking to some head of a German family office, and they're just trying to align on the right form or
the Germans probably wouldn't even let you do it until it's all right too, because they're picky.
They're exactly picky. So what we effectively do is we help the funds, right, the GP, onboard their investors very quickly and efficiently into their investment vehicles. And what we do is we take these static LPAs and we consumerize them, right, to make them really dynamic and really easy for people to fill out. So the best analogy, again, is just the TurboTax analogy, where we now just build logic around all of these fields so that the investor is never presented with extraneous information.
And once they filled out one, I'd imagine it's much faster to fill out the next one if you have all the AI around that.
All the AI, all the data. And I think that's the whole point here, is where you can sort of build up a sort of a common data picture, I think, of these investor profiles, and no investor wants to fill out the same information. I mean, that's like literally the biggest pain point, is like, if I invest in fund A, I have to go through this process, and then you have slightly different docs asking for the same information in fund B, and you have to go through the same thing again. And how
big is this ecosystem? This is like a few thousand investors doing this? Is it like, how many investors are on there in the world solving these types of problems for?
Well, I mean, there are low tens of thousands of GPs globally, right, across hedge, venture. U.S. is the largest market. You've got private equity. You've got Europe after that. I mean, right now we've had 22,000 investors go through Anduin. We have about 4% of the global private market, so $40 billion processed through Anduin.
So you think maybe that means there's probably like several 100,000 of these?
Yeah,
investors?
I think more critically, I think there's this huge democratization and retailization trend that's occurring in the private markets, where we're building Anduin, I think, not just for the current GPs and the current LPs. It's really about the next wave of investors that want access to the space. Investors want access to the private markets. They want the diversification. They want those returns. But critically, you look at these GPs, they all want access to these smaller investors.
So you want to be in smaller investors, but it's really high cost right now.
It's high cost
to do the bureaucracy and the legal forms and stuff.
Absolutely. I mean, for these funds have never truly had to operate. They have these back offices that are largely dealing with largely manual processes. They're slammed, and they've never really had to operate at sort of enormous amount of scale and interfacing with these smaller check sizes. But I think every single back office and middle office that we talk to, like the holy grail for them is like they want to diversify their LP base, right? And everyone's just trying to figure out how can we operate on board, but also successfully interface with these investors at scale while providing an awesome investor experience. I think that's like the broader story here is how do we go from providing one unhappy path to all of our investors to providing these configured happy paths for each individual investor? Because I think the end outcome, people really want loyal investors that invest and reinvest and grow.
They don't want them to think about any of these issues.
Being dissatisfied with med school, but on the other hand, being really excited about what my friends were doing, I ended up finding my way to Palantir, where I joined in right at the end of 2013 to help build out their commercial healthcare business.
And so you joined Palantir after a year in med school, and you started learning more about healthcare there. What'd you learn at Palantir?
Well, I think that there's actually there's a lot of specific things to how healthcare businesses work and how the industry works. But I think that the biggest learning from Palantir is this sort of like broader sort of observation on how businesses can be the best tools to solving certain problems in the world. I think that, again, coming out of a place like Yale, you have certain mental models about, problems that policy can solve, problems that nonprofits can solve. And what I saw at Palantir was a scaled business actually doing a lot of really important work. And I think that that's not necessarily the mental model that a lot of students at top schools have.
Students at top schools assume you're going to solve the problem by doing science or doing policy but they don't assume you actually go into a business and fix things.
They assume you go to a business to make money. But in fact, like making money and having impact at scale are one and the same. Think about the pandemic we just experienced. Amazon was far more helpful to many Americans than anything the government did. And I think that that's something that a lot of college students don't necessarily see.
That makes sense. So healthcare seems to be a particularly broken part of the economy. Your costs go up every year. Doctors are burnt out. Patients aren't often having a good experience. Why is this happening? What's going on?
Yeah, all that is true. And I think that one of the reasons why this is so difficult to solve is that you can't really, say it's just, corporate greed or just monopolies or just regulatory issues. It's death by 1,000 cuts in healthcare is my view. But if you had to distill it down, if you had to really sort of like put it into sort of one solvable problem, I think we can frame it as a productivity problem. I think that in healthcare, as it has become a bigger and bigger part of our economy, multi-factor productivity has actually been declining.
Multi-factor productivity just means that just how productive and efficient the system is overall.
Yeah, exactly. How much output are we getting for the same labor inputs?
For the same number of nurses and doctors and hospital buildings and everything else. And why is it going down? Why is productivity going down?
It's a really good question. I don't know if I think there's PhD theses to be written about this. And I think the archaeology exercise isn't necessarily as interesting as thinking about how we actually solve this problem. And so the fact is, as we have been spending more in healthcare, we have been getting less for each incremental labor input. And I think, when I think about solving problems in healthcare, I think about, hey, how can we reverse that trend?
And it seems like there's at least a few major highlights. I guess there's no exact answer, but like there's local monopolies is a problem. There's the fact that the incentives of the hospitals and the doctors isn't always aligned with whatever's most efficient. And there's all sorts of players who have incentives wrong. There's all sorts of players who capture regulators.
That's right. So there's a bunch of specific sort of policy issues that I think we can get into. I think that maybe one framework we can use to think about it is there's policy levers, and then there's a role for industry and entrepreneurs to play as well.
So entrepreneurs can solve some of the problem, and you're gonna need policy to solve some of the problem as well.
Policy kind of sets the sort of like rules of the game. It sets the boundaries within which entrepreneurs can sort of operate and build.
It seems to me like the boundaries that have been set in some cases accidentally made it harder to compete and fix the problems, right? So if you set the boundaries too narrowly, to have the rules too prescribed, you kind of lock in some inefficient things.
Yeah, you're absolutely right. I think that this is definitely part of what we've been experiencing in healthcare, where the way that we pay for healthcare in this country predominantly is what's called fee-for-service reimbursement, and the government defined a set of codes that describe services that you can deliver. And most doctors today simply get paid for the services they deliver.
How many sorts of codes are there overall?
Tens of thousands of
Tens of thousands.
codes.
So more than there are bones in the wrist.
More than, well, I can't say my memory is perfect, but I don't think there's more than 10,000 bones in there. But there's a lot of these codes, and ultimately as a physician, I don't think that these are like bad or malicious people for the most part. But you're ultimately rewarded for doing stuff.
Does anyone know the tens of thousands of codes? No one does, right? They just know there's some codes in their area, and then they look them up for things.
Yeah, that's right. Maybe someone does. I don't know. That person has probably too much time in their hands.
And are more codes getting created all the time for new treatments that come up, or do you have to create a new code? I remember we were doing AI diagnostic. We had to create a new code, I think, for an AI diagnostic for something.
That's right. One of our companies, Digital Diagnostics, has the first FDA-approved autonomous AI for conducting diabetic retinopathy screening. Huge problem.
If you have diabetes, you might go blind. You can check it so you don't go blind, and you use AI to do it more efficiently. And they actually had to lobby for code, right?
You got it. There was no code for AI to perform a diabetic retinopathy screen. And so even though we had the technology, for years we couldn't get paid for it. It was silly. And this is something we could have deployed across the country by now. And instead we got stuck in a regulatory morass. And so these codes, I think, this isn't the be-all and end-all of problems in healthcare, but I think they do create certain issues. The diabetic retinopathy screening example is one of them. I also think the broader point to make here is these codes reward doctors for doing stuff.
Yeah, so it's fee for service versus for treating a patient holistically.
That's right. They don't reward health outcomes. They don't reward value necessarily.
So I could look at a patient and what they're going to need over the next year. And if I'm really good, I could say, okay, here's the things we should do to this patient so we don't need to treat them a year from now. And that would actually I'd get paid less, but we'd have better outcomes.
You got it.